তো কালকে আমরা বলছিলাম যে আমাদের ফার্স্ট ইউনিটটা হচ্ছে ইলেক্ট্রোস্ট্যাটিক্স। সো electrostatics, what is electrostatics? Now statics, electrostatics is a unit where we'll study the charges are at rest and properties associated with the charge at rest. एखने इसमें हम लोगों को केवल वो पढ़ना है कि चार्ज रेस्ट में रहेगा और उस चार्ज का जो बहुत सारे प्रॉपर्टीज होगा वो प्रॉपर्टी रेस्ट में होते हुए जो प्रॉपर्टी होगा उसके स्टडी होगा। इसमें इलेक्ट्रोस्टैटिक्स में कभी भी चार्ज मोशन पे नहीं होगा। तो फर्स्ट यूनिट फर्स्ट चैप्टर था इलेक्ट्रिक चार्ज एंड इलेक्ट्रिक फील्ड। नाउ लेट्स स्टार्ट विथ व्हाट इज चार्ज। नाउ व्हाट इज चार्ज যদি আমরা বলি তো আমরা ক্লাস 11-এ we have come to know there are four types of forces: gravitational forces, electromagnetic forces, weak force and your strong force. তো ইলেকট্রোম্যাগনেটিক ফোর্সের জন্য যে রেসপন্সিবল ইলেকট্রোম্যাগনেটিক ফোর্সের জন্য যে রেসপন্সিবল, this is known as your charge. Means charge is the cause of electromagnetic force. So gravitational force, mass is responsible. Gravitational force, we know. Now electromagnetic force is produced by the charges. Now means আমরা যখনই চার্জ বলবো তো আমরা বলবো যে চার্জ is that thing, is that property of a body which is a fundamental property for which we will get the force known as your electromagnetic force. So electrostatics যেমন বললাম যে study the charges are at rest. We'll study the charges are at rest. And nowhere we are going to study the charges at motion. যখন আমরা charges motion-এ পড়বো that will be the different topic. So whenever you study this total unit, always you have to think the charges are at rest. Okay, so electrostatic first unit. Now what is charge and what is the electrostatic? Now let's discuss now some basic property of your charges. So you see this is so basic property of charges. So first is your charge is quantized. It's very important. Charge is conserved. Now we have the idea of the conservation energy we have learned, and conservation momentum and all these things. Charges are additive. Now let us first focus on charges are quantized. Charges quantized বলতে আমরা কি বুঝি? Now একটা প্রোটন কিংবা একটা ইলেকট্রনের যে বেসিক চার্জটা হচ্ছে সেটা ভ্যালুটা হচ্ছে আমরা জানি 1.6 approx 1.6 10 to minus 19 Coulomb. So positive or negative. Now next একটা বডিতে কত চার্জ থাকতে পারে? তো quantization of charge বলছে this is n times of e. N times of e. What is n? N is an integer, means it's plus 1 2 3 4 all these things. So যদি কোনো বডিতে চার্জ থাকে সে আমার এটা হচ্ছে আমার বেসিক চার্জ সো কোনো বডিতে চার্জ কত থাকতে পারে? 2 times of this, 3 times of this, 4 times of this, but half times of this is not possible. মানে এটা হাফ টাইমস পাবো না, 3/2 times পাবো না। চার্জেস আর কোয়ান্টাইজড, এইটার মাল্টিপল অফ দিস ইন্টিজার, রাইট? সো এটা যদি আমার এটা আমার একটা সিঁড়ি, রাইট? সো দিস ইজ স্টেপ, দিস ইজ ইয়োর স্টেপ, রাইট? সো এটা যদি আমার 1.6 10 to minus 19 হয়, এটার পরে এটা ডিস্টেন্স যদি 1 হয়, so this next after going 1 we'll get this, then 1 2 we'll get another, 3 another, continuous না, ফ্র্যাকশন হবে না। So কোনো বডিতে চার্জ cannot be fraction of this amount. It will be always multiple of n. What is n? N is the integer. Fine. So this is very important. এখান থেকে আমাদের নিউমারিক্যালসও করতে লাগতে পারে। আর চার্জের কনজার্ভড এটা বুঝি যে একটা বডিতে চার্জ যদি যায় আর একটা বডির চার্জ যদি নেয়, সো চার্জ উইল বি কনজার্ভ, প্লাস মাইনাস যেটা থাকবে চার্জ উইল বি কনজার্ভ। চার্জ এডিটিভ, কোন একটা বডিতে চার্জ আছে, সো টোটাল চার্জ যত সে আমরা কিউ চার্জ আছে, সো কিউ চার্জ উইল বি সাম অফ দ্য চার্জেস, এখানে প্লাস কিউ ওয়ান, এখানে প্লাস কিউ টু, এখানে মাইনাস কিউ থ্রি, অ্যান্ড দিস ইজ অল দিস থিংস, সবটা প্লাস মাইনাস করে যেটা হবে উই ক্যান have the addition of this total charge mile ki hobe, it will be additive of all these charges. The charge contained by a body, this plus or minus total charge, we have to algebraic sum of all the charges, সবটাকে চার্জটাকে অ্যাড করে আমরা টোটাল চার্জ বডিটার পাবো। ফাইন। সো চার্জেস আর কনজার্ভ, চার্জ ইউ ক্যানট ক্রিয়েট, it can go from one body to other, আর charges are quantized. These are the basic properties of charge. These are the basic property of charge. Charge is quantized, conserved, additive. Fine. So Q, charge of the body, N so fundamental charge এটা হবে, আর N টা হচ্ছে আমার integer, right? Next আমরা কি করে একটা বডিকে চার্জ করতে পারি? How can you make a body to be charged? আমরা একটা বডিকে চার্জ কিভাবে করতে পারি? So you see, we can make a body charged by এটা আমরা জানি ফ্রিকশন মিনস, আমরা আগে যদি ঘষাই একটা বডিকে, যে দিস ইজ দ্য স্ট্রাকচার অফ অ্যাটম, দিস ইজ ইউর নিউক্লিয়াস, ইউ নো, ইলেকট্রন আর দেয়ার, আউটার মোস্ট ইলেকট্রন, যদি তাকে আমরা ফ্রিকশন করি, সো ইট মে লুজ ইলেকট্রনস অ্যান্ড সামটাইমস ইট মে গেট ইলেকট্রনস, সো ইট মে বি চার্জড। বাই ফ্রিকশন উই ক্যান মেক এ বডি চার্জড, এটা আমরা জানি। বাই কন্ডাকশন অ্যান্ড বাই ইন্ডাকশন, তো কন্ডাকশন একটা মেথড, ইন্ডাকশন একটা মেথড, যে আমরা বডিটাকে চার্জ করতে পারি। কন্ডাকশন বোঝার জন্য, কন্ডাকশন মিনস কন্ট্যাক্ট, ওকে, কন্ট্যাক্ট, কন্ডাকশন, আমরা একটা বডিকে চার্জ করতে পারি বাই কন্ডাকশন, মানে কন্ট্যাক্ট করে। কীরকম কন্ট্যাক্ট করে? ধরো এটা একটা কন্ডাক্টর, একটা বডিতে চার্জ ছিল আমার সামথিং, সো ইফ আই মেক দ্য কন্ট্যাক্ট of this body with this, if I make a contact of this body with this body, then charges will transfer to this, so charges will transfer to this, so it will be charged. So এখানে আমার চার্জ q ছিল, so say same shape a body, so it will q by 2 charge will go, it will over q by 2, the same shape যদি হয়, তো this is charge is conserved, so q by 2 যদি এখানে যায়, এখানে q by 2 should remain, so charge will be transferred to this by conduction, I can make a body charged. আরেকটা মেথড আমরা যেটা বললাম, this is your conduction by induction, charge by induction. So এটা যদি this is contact, this is not contact, this is from distance, not touching, so you will make a body charge not by touching but by from a distance. How? Say মনে করো this is a charged body, this is a charged body and this is uncharged body, so এখানে this will have protons and neutrons, equal numbers of protons and neutrons in this body. এবার this is negative charge, so negative charge এই বডির পজিটিভ চার্জটাকে একদিকে পোলারাইজড করবে, so when positive charges will come here, negative charge will go by repulsion, this will be repelled by this, so polarization, charge will come here, positive, negative will go there. This process of charging is very important. We have to discuss these things in many parts of our this chapter, I mean this unit. So কি হলো, this is positive, negative, so what happens? Nothing. But if we connect a conductor to the earth, then what will happen? You see, positive charge, negative charge, this is bounded, it will keep the positive charge bounded, so negative charge will pass through, এখন যদি আমি একে ডিসকানেক্ট করে দিই, এটা যদি সরিয়ে দেই, তাহলে এটা কি হয়ে গেল? পজিটিভ চার্জ। সো ইন্ডাকশন দিয়ে ইফ আই ওয়ান্ট টু মেক এ বডি পজিটিভ চার্জ, দেন হোয়াট শুড আই ডু? I have to bring a negative charge body. If I want to make a negative charge body, if I bring a positive charge body, so it will be here negative charge will come, charge separation, positive will go there, If we make it earth, then it will be neutralized, then it will be your negative charge body. So I can make a body charged by induction also, and this process of charging a body is very important for us. So then let's come to some let us discuss few important definitions. We'll have to discuss it. So some important definitions that are barbar. We'll get many times this point charts, test charts. We'll get it, point charts, test charts. So you may be confused, what is point charts, what is test charts? So all the definitions will get point charts and test charts. Let's bring a test charts. They'll show like this in the box. Now point charts, you see point. So we discuss in our class 11, there is nothing called big, small, large, etc. This is only the relative ideas. So point charge here is point with respect to the distance between them. When I consider the charge is point charge, so with respect to the distance from where I am considering it, this with respect to distance, this is very small. So point charge is the charge which dimensions is relatively very small relative to the distance from which I am considering this. So this is a point charge. Don't be confused. Now test charge value is very small because we want to study the electric field because of another charge. একটা body charge body, তো তার property কিছু study করতে চাই, then I have to put a test charge whose value is very negligible. Its value is very negligible. In theoretically, this tends to be 0. So charge of this value is very small, so that it does not affect the distribution of charges. The charge distribution আছে সেটা যাতে effect না করে. So whenever I say test charge, I have to keep in mind the value of this charge is very small. Point charge means the charge is the value of this charge or the dimension of the charge is very small relative to the point from which I am considering the charge. Then as you know, in our there's younger, whenever class 4, 5 or 6, we have come to know the positive charges repel, or like charges repels, and opposite charges attract each other. Now it is the time to know with what magnitude of charge force they are attracting. Means this will be attracting or repelling. So this will be repelling, this will be repelling, this will be attracting, no problem. But what is the force with which they are attracting or repelling? So to understand this, the Coulomb was this man, the scientist, who developed a formula by experiment, and he said if this is a charge, point charge, this is a point charge, this is a distance between them, then force is proportional to product of the charges and inversely to the square of the distance. You have read this in Newton's law of gravitation, G mm by r square. So it is something like this, square law. So this is r means distance between the point charges, and this is the product of the charges. The Coulomb's law says that force between the two charges is directly proportional to the product of charges and inversely to the square of the distance. So this is the force. Now as you know, this is proportional, so I have to make it equal. So to make it equal, I'll give a constant k. So this k is again important. The value of k depends on two factors. What are the factors? The units you are considering. This units will be there. Force, if you take your SI system, then this will have some specific dimensions. If you take in CGS, it will be specific dimensions. So the value of this is depending on the units you are considering in your problem, and the medium between the two charges. So I have this is charge, this is the charge, right? So what is the medium in between the charges is very important. Now nothing to be confused, very easy. See, k depends on two factors. One, the units you are considering, and the medium between the two charges. medium. Now unit, we consider CGS and SI. Medium, maybe air or vacuum, same thing, air or vacuum we may consider same, and medium may be other medium also. Now if it is CGS and air or vacuum, then K is 1. So formula comes out to be F is equal to Q1 Q2 by R square. Now this is rarely we require, we never use these things. Now if it is SI and air or vacuum, then K value is given by, it is proved by mathematics, by experiment, which value makes these two sides equal, then the value comes out to be 4 pi 1 by 4 pi epsilon naught. So K value is 1 by 4 pi epsilon naught. So this is now K, so 1 by 4 pi epsilon naught Q1 Q2 by R square. This is the magnitude of the force between the two charges. Nice, magnitude of the force between the two charges. Now you know this, all these things are not new. Now this is new for you. This is known as your epsilon, and this is not known as epsilon naught. Epsilon naught. And in physics it is known as your, the symbol is known as epsilon and epsilon naught, and in physics it is known as absolute permittivity. Permittivity. Absolute permittivity. Absolute permittivity because the medium is air or vacuum. So what is the conclusion? If it is CGS and air or vacuum, so K is equal to 1. This we hardly require this in our class 12. In class 12 we have to use most of the time, that is SI and air or vacuum, and K value is 1 by 4 pi epsilon naught. So epsilon naught is the absolute permittivity of the medium, right? And if you put the values 4 pi and epsilon naught, you will get the in books here all these values. So value comes out to be approximately 9 into 10 to the 9, and if you put the your dimensions and units, then Newton meter square per Coulomb square. So the Coulomb's law comes out to be this for air or vacuum and SI unit. Now if it is not air or vacuum, other than the air or vacuum, then what will happen? We'll discuss this later on. We're coming to this point. Now let's finish with the idea that Coulomb's law only holds good, as I said, point charges, not for the distributional charges. It should be point charges. For distributional charges, we cannot use exactly this formula. For using this formula for other than the point charges, we have to make some other arrangement, some integrations to be used. You will do some numericals on this. So don't be confused. For point charges, your Coulomb's law is very good, is enough to explain. But if it is not point charge, okay, we have to modify in other ways by using our calculus, our friendly calculus, your integral calculus. We'll use this in numericals. Now if you put the dimensions of epsilon naught, then the dimensions is this. Sometimes is asked in the exam. Very easy. Put the value dimensions of Q1, Q2, 4 pi, no dimensions, R square is all these things. So these are dimensions of your epsilon naught. Now as I said if the charges are not kept in air or vacuum, then we replace epsilon naught by epsilon. Nothing, epsilon, not here. So it is known as permittivity of that medium. So it was absolute permittivity, and it is known as your permittivity of that medium. Permittivity, it is absolute permittivity. Okay. Then we'll come to another parameter is known as your relative permittivity of the medium. Mind it, relative permittivity of the medium. It is also known as dielectric constant of the medium, or sometimes you may call it specific dielectric capacity. So what I said, this is absolute permittivity of the medium if air or vacuum is the medium. If it is not air or vacuum, then you have to replace epsilon naught by epsilon. We call permittivity of the medium, not absolute. And we use another term, relative permittivity of the medium. This is also known as dielectric constant of the medium, or sometimes specific dielectric capacity. So this is your first video. Please go through this. If you have any confusion on this, then we'll discuss it over telephone. You may text to me. I'll try to answer your questions, your queries. Thank you.